Okay, so we finished up that mess. So let's go on to the next example here. So the circuit's been labeled for us. Okay, 1, 2, 3, 4, 5 in terms of the resistors, and it looks more complicated, but we're going to step through this. So we're just going to go V, I, and R. We know we have up to 6 circuits here. So 1, 2, 3, 4, 5, 6, and our total. We're going to fill out the chart, and the first thing we do is fill out what we know. So working our way around. Here's my battery. I have a 15-volt battery, so that would go in the chart there. Moving my way to the first circuit. So R1, it's 15. At R2, I know the resistance is 5. R3 is 12. R4 is 8. 6 and 14. So we're only given, and these are, the reason I'm doing these ones, they're the hardest ones, we're only given resistances. This is the hardest type of question. If we have anything else inside, if you're given a current, it makes these questions so much easier because you can start playing around with it. And you'll see that when we work through them together. All right, so the only way I can do this is to break the circuit down into its basic form. So I'm going to ignore the chart for a minute, and we're going to take this circuit, and we're going to simplify it. So again, I know it's supposed to be 15 of those cells, but I'm not going to go all the way and do that. So there's the first circuit, so that's 15 ohms. Second circuit, it's 5 ohms. Now I'm going to break this into, these two are going to get combined here. So 3 and 4 are going to be combined. And the reason they're easy to combine is because they're in series. Okay, they're in series, so I just got to add them together. So 12 and 8 is 20 ohms. The other two, numbers 5 and 6, also in series. 6 and 14 is also 20 ohms. So, coincidence it worked that way, but all the same. Going down, I now need to take my parallel circuits here, and we need to combine them together. So, using my formula, 1 over RT equals 1 over R1 plus 1 over R2. 1 over RT will equal a 20th plus a 20th. 1 over RT equals, so we got 1 divided by 20. So those add up to 0.1. Flipping it or taking it to the exponent -1, the equivalent resistance is 10 ohms. So that means that my next drawing, 15 volts, 15 ohms, 5 ohms. Now I only have 1 over there because they got combined, is 10 ohms. Now there's only one pathway, so I'm down to a series. So that means I can add up my total resistance for this whole circuit. It's going to be the 15 plus 5 plus 10. So the entire resistance for the circuit is 30 ohms. So I now know in my chart it's 30 ohms total resistance. Now we start filling in the information. V equals IR, so that would mean that 15, all right, so the reason we have it this way, it's easy to do the calculations. 15 divided by 30, the total current in this circuit is 0.5. Okay, so that's what the total current is. So that means when the current leaves the battery, I'll try this in green over here, when we leave the battery, you are moving at 5 electrons per second. Okay, through the first one, there's only one pathway. So that means all the current has to go through the first circuit. So that's 0.5. And since I'm on a roll, all the current has to go through the second one. So that means the current through resistor 2 is 0.5. As soon as I get to a junction point where it splits, I'm going to stop and I'm going to fill in my chart, figure out what information I know and what I don't know. So, going by my chart, 0.5 times 15. So I started with 15 pretzels. I ate 7.5 of them at the first point, or the first resistor. Then I ate 0.5 times 2 is 2.5 pretzels. Okay? So I'm going to do a quick calculation here. So I started with 15. I used 7.5 to the first one, 2.5 to the next. So how many pretzels do I have left in my hand? So 15 minus the 7.5 minus the 2.5. I have 5 pretzels left. All right? So that means that at this junction point right here, I have 5 volts or 5 pretzels to get here. So that means that I don't know how many pretzels. The last example I did, there was only one resistor on one of the pathways, but these have 2 resistors. So what I'm going to do is I'm going to go down to my next diagram for a second. Because if I'm here, same location as I had above, both pathways, there's only one resistor in there. So I'm going to use V equals IR to do a calculation. So V equals IR. So I know that I have 5 pretzels to go down path 1 or 2. In this case, they're the same, so we only have to do one calculation, but usually they'd be different. So I have 5 pretzels to go down this pathway right here that I'm highlighting. Okay? So I want to know how much current will go down there if the total resistance of that pathway is 20. So 5 divided by 20, doing that calculation, is 0.25. So you're probably sitting there saying if the resistance is the same, it would have just split evenly. I agree 100%, and if that's the case, you don't have to do this calculation. I just wanted to show you that that calculation, this is how you would find if they weren't both 20, so let's say one was 20, one was 30, I would know it's 0.25 and the rest of the current went down the other pathway. But because the resistances are the same on both pathways, you know the current split evenly. So to go down 3 and 4, it was 0.25. Okay, so going down this pathway here, the current has to be the same going through both. Similarly, those two will have to have the same current, and in this case, because the resistance was equal in both directions, that current split in half. And there is our calculations. So we know that 0.25 times 12 is 3. 0.25 times 8 is 2. 0.25 times 6, 1.5. And 0.25 times the 14 is 3.5. And you'll notice these two guys add up to 5. And these two guys add up to 5 because we had 5 pretzels to get from that point to that point. Okay? So you had to eat them all no matter which way you went. Lots of fun, eh? There's your final answer. So I think there's 6 or 7 of them to try. They'll be frustrating off the start. Some of you, this will make complete sense and you'll fly through. It's funny. Some people immediately see how to do it. Some people, you need help. So don't be afraid to ask questions, help each other out, and we'll see how it goes. But like I said, once you do the last one, people are feeling more and more comfortable with it. So good luck.